Have you ever stepped outside on a crisp morning, glanced down at your driveway, and suddenly felt that heavy, sinking feeling in your chest? I did. Just last week. Right there in front of me was a jagged gray line cutting straight across the concrete, slowly spreading like an open wound across the face of my home. It had started as nothing more than a tiny hairline crack, the kind of thing I had easily ignored through a couple of winters. But water, ice, and time never stop working. Now that tiny fracture had opened into a wide crack, while a dark green biological biofilm crept along the shaded edge beside my garage, making the entire entrance look worn, tired, and neglected. In a panic, I did what most homeowners would do. I called a contractor. He pulled up in a shiny truck, walked across the driveway, tapped his boot against one hollow-sounding section, and let out a long sigh. "The subbase is failing," he told me. "A simple patch isn't going to save this. You need to tear the whole thing out and pour it again. It's a major job. We'll need a jackhammer, a skid steer, and an entirely new slab." Then he gave me the number. $8,000. I just stood there, stunned. I felt defeated, trapped in this modern cycle of home maintenance where everything seems designed to fail and the only solution is another crushing bill. But as that contractor drove away, something inside me pushed back. My home channel is called The Roots Survived for a reason. We don't simply surrender and pay the corporate tax on what we haven't been taught. We look backward into history, outward into nature, and deep into the roots of science to find answers without a contractor lobby standing over our shoulder. So I started digging. I stayed awake until 3 o'clock in the morning, translating old civil engineering journals and studying traditional Japanese architecture and maintenance philosophies. What I found completely changed the way I looked at concrete. And it may change the way you look at your home too. I discovered a chemical reaction that had quietly been used on military runways, airport terminals, and enormous sports stadiums since the 1930s, to help stop concrete from cracking and allow it to heal from within. A solution costing less than $30, requiring absolutely no heavy machinery, and eliminating the need for a contractor. And then I found something even more fascinating. Traditional Japanese craftsmen had developed a philosophy that transformed cracks from ugly signs of structural failure into breathtaking works of art, a philosophy reaching all the way back to the 15th century. So put down the phone, cancel that contractor, and stay with me. Today, we're going to open the vaults the construction industry welded shut. We're going to heal concrete permanently, transform the scars of our homes into veins of gold, and discover why simple, honest science can outlast the expensive temporary bandages sold by the modern repair industry. Section 1. The multi-billion-dollar crack. Why concrete fails. Before we can talk about the cure, we first have to understand the disease. Why does concrete crack in the first place? Almost everyone will tell you the same thing. Concrete just cracks. But that is a very convenient answer for an $8 billion repair industry that depends on your driveway splitting every few winters so the replacement cycle can continue. When a concrete slab is first poured, it looks like one solid piece of artificial stone. But under a microscope, concrete is actually much closer to a hard, rigid sponge filled with millions of tiny interconnected pores and capillary channels. As the concrete cures, some of the water mixed into the cement slowly evaporates, leaving behind an enormous network of microscopic empty spaces. Those pores become open invitations for water. During rainy weather, moisture penetrates deep into those capillary channels and begins soaking the concrete from the inside. Then winter arrives. When that trapped water freezes, its volume expands by roughly 9%. Inside millions of microscopic pores, tiny droplets of water suddenly become miniature hydraulic jacks. They push outward with tremendous force against the rigid internal walls of the concrete. Eventually, those internal tensile stresses become greater than the material can withstand, and a microscopic tear forms. Then the weather warms. More water enters. The next freeze comes, the water expands again, and that microscopic fracture grows. Before long, the tiny fissure travels all the way to the surface and becomes the familiar hairline crack you can see with your own eyes. Once that crack opens, the problem gets worse. Water pours through the opening and reaches the subgrade, the compacted soil beneath your driveway. It softens the ground, washes away portions of the base, and eventually creates hollow, unsupported spaces beneath the slab. Concrete has almost no tensile flexibility. When the slab begins to bend over that empty space, the rigid surface snaps, and a serious structural fracture appears. What do most of us do next? We buy a $15 tube of gray concrete caulk, squeeze it into the crack, smooth the surface, and assume the problem is fixed. But by the following winter, that cheap surface sealer has often shrunk, dried, and separated from the crack edges. Water slips straight back into the opening, freezes again, expands again, and tears the repair apart, leaving the crack even wider than before. Section 2. The Lost Alchemy of 1947, The History of Liquid Glass. To find the solution, we need to travel back to 1947, into the rubble and destruction of post-war Japan. A group of brilliant Japanese civil engineers faced an enormous challenge. Their country needed roads, bridges, and building foundations repaired after the devastation of war, but they had almost no money and virtually no access to heavy construction equipment. They could not simply tear out and replace millions of tons of fractured concrete. They needed something inexpensive, fast, logistically simple, and permanent. While searching through old scientific records, they came across a short reference to a chemical reaction documented in a German engineering journal from 1931. The record described a compound that did not simply coat the surface of concrete like a temporary band-aid. Instead, it penetrated into the pores and triggered a chemical reaction inside the material itself, allowing the concrete to heal from within. That compound was sodium silicate, Na2SiO3, commonly called liquid glass or water glass. When post-war engineers applied this clear, water-like liquid to damaged infrastructure, the results seemed extraordinary. Roads and bridge decks treated with the silicate compound reportedly showed a 67% reduction in crack progression over a 10-year period, compared with conventionally patched roads. The concrete became dramatically denser, more resistant to water, and significantly stronger. But for decades, the American construction and concrete repair lobby made sure this simple chemistry remained almost invisible to ordinary residential consumers. They didn't ban it. Instead, it was quietly pushed out of consumer manuals, removed from construction curriculums, and kept largely inside heavy industrial and military applications. During World War II, the United States Army Corps of Engineers used sodium silicate as a standard penetrating treatment on military airfield runways and harbor structures throughout the Pacific and European theaters. It became standard protocol because military infrastructure could not tolerate constant maintenance shutdowns or structural failures caused by concrete cracking beneath the loads of heavy bombers. Yet walk into the driveway maintenance aisle of your local Home Depot today and look around. What do you find? Rows of temporary acrylic coatings, silicone caulks, and expensive surface sealers that can begin peeling beneath hot vehicle tires after only a few summers. Meanwhile, the sodium silicate solution, the very same molecule used on military runways, remains hidden in plain sight. Section 3. The Healing Reaction. How the mineral works. Now let's get into the hard science. This is material chemistry that has been studied, documented, and tested in civil engineering laboratories for nearly a century. When Portland cement is mixed with water, a major chemical hydration reaction begins. The calcium silicates react with water and produce two important compounds: calcium silicate hydrate, known as CSH gel, and calcium hydroxide, often called free lime. CSH is the true structural hero of concrete. It forms a dense, insoluble crystalline matrix that locks the sand and gravel together, giving concrete its hardness, strength, and structural integrity. The second product is calcium hydroxide, or free lime, And this is where the hidden weakness of modern concrete appears. Up to 25% of the hardened volume of your driveway can consist of this soft, soluble, vulnerable free lime. It contributes nothing to the structural strength of the slab. Instead, it sits inside the capillary pores like a weak, powdery salt, waiting for rainwater to penetrate, dissolve it, and eventually carry it toward the surface, where it appears as those familiar white powdery stains known as efflorescence. Every pore occupied by that free lime becomes another pathway for water infiltration, freeze-thaw damage, and eventually structural cracking. And this is where the magic of the $3 mineral begins. When liquid sodium silicate is applied to concrete, silicate molecules move deep into the microscopic pores and capillary channels through a process known as capillary absorption, the same physical force that pulls water upward through a paper towel against gravity. The moment sodium silicate encounters the dormant, unreacted free lime inside those pores, a secondary hydration reaction begins. The silicate reacts with the weak free lime and produces fresh, dense, insoluble calcium silicate hydrate crystals directly inside the empty spaces, Na2SiO3 plus CaOH2 plus H2O CSH plus 2NaOH. This reaction does more than simply fill a pore. It completes a chemical process that the concrete began decades earlier but could never finish by itself. The weak, water-soluble free lime is chemically transformed into the same hard, load-bearing crystalline material responsible for much of concrete's strength. Research from the University of Ghent showed that sodium silicate treatment increased concrete compressive strength by as much as 31%. Other studies found that this internal densification reduced the water absorption coefficient of concrete by 65%, permanently. Section 4. Golden Scars, the Philosophy and Beauty of Kintsugi. But what happens when the cracks are no longer microscopic? What if a wide, jagged fracture already runs straight across your driveway, far too large for a liquid densifier alone to bridge? In the West, our first instinct is usually to hide the damage. We buy gray caulk and concrete patching compounds, desperately trying to match the faded, weathered color of the existing slab. But here is the uncomfortable truth. No matter how carefully you match the repair material, the patch still looks like a patch. An ugly gray scar, reminding you of deterioration, poor workmanship, and a home that looks neglected. Japan offers a completely different way of looking at broken things. That perspective is rooted in wabi-sabi, the philosophy of discovering beauty in imperfection, weathering, age, and flaws. From that philosophy emerged, in the late 15th century, the legendary Japanese repair art known as Kintsugi, literally meaning golden joinery. According to historical accounts, Kintsugi began after the Japanese Shogun Ashikaga Yoshimasa sent a valuable cracked Chinese ceramic tea bowl back to China to be repaired. When the bowl returned, it had been joined with heavy, unattractive metal staples. Yoshimasa was deeply disappointed. He challenged Japanese craftsmen to create a more elegant and beautiful method of restoring damaged ceramics. Their solution was revolutionary. Instead of hiding the cracks, they would celebrate them. The craftsmen repaired the broken pieces with a natural resin made from the sap of the lacquer tree, known as urushi, and then covered the still wet seams with brilliant pure gold powder. The result was breathtaking. The repaired vessel became a unique and highly valued object, often considered even more beautiful than it had been before it was broken, because the golden cracks now carried a visible story of resilience, history, and survival. The philosophy of Kintsugi rests on 3 pillars. 1. Wabi-sabi, embracing wear, age, deterioration, and imperfection as sources of artistic character. 2. Matanai, a deep sense of regret when something valuable is unnecessarily wasted or thrown away. 3. Mushin, the Zen idea of no mind, representing calm acceptance of change and impermanence. When we apply this same physical and philosophical idea to a cracked concrete driveway, our entire relationship with the damage begins to change. Modern high-performance engineered polymers can be mixed with brilliant metallic pigments to create a dramatic architectural version of a Kintsugi concrete repair. Imagine stepping outside in the morning and seeing a jagged, shimmering vein of gold catching the sunlight across your driveway. Suddenly, the structural flaw becomes something deliberate, a unique statement of craftsmanship, character, and pride. Section 5. Stage by Stage. The Physical Restoration Guide. If you're ready to carry out this permanent, beautiful restoration on your own driveway this Saturday afternoon, here is the complete stage-by-stage process. We'll break it into 4 precise physical stages. Stage 1. Debridement and profiling. Preparation. Start with a hammer and a cold chisel and work along the entire crack. Carve the opening into an inverted V profile, making the crack slightly wider at the top than it is at the bottom. This technique is known as keying the crack. It creates a mechanical lock that helps prevent the repair material from being forced vertically out of the opening under vehicle loads. Next, scrub the inside of the crack aggressively with a stiff wire brush. Remove every piece of loose gravel, dirt, and efflorescence you can reach. Then use a powerful shop vacuum or compressed air to remove every remaining particle of dust. If dust remains inside the crack, it acts as a bond breaker between the concrete and the repair material. Stage 2. Subgrade assessment and base stabilization. For cracks wider than 1/4 inch, tap along the concrete edges with a hammer. Listen carefully. If you hear a dull, hollow sound, that section of concrete may have separated from the soil base beneath it and is essentially suspended over an empty space. For smaller hollow sections, you can inject a rapid-setting hydraulic cement grout, such as Crichton Crystal Plug, through small drilled holes to fill the void and stabilize the base. For deep, wide cracks, insert a closed-cell polyethylene foam backer rod. Press the rod down into the channel until it rests roughly 1/4 to 1/2 inch beneath the concrete surface. The backer rod creates a solid base for the repair material and prevents what is known as three-sided adhesion, a condition that can lead to premature failure. Stage 3. The molecular heal. Sodium silicate application. Lightly dampen the concrete with ordinary tap water. The goal is to create what is known as a saturated surface dry, or SSD, condition. The concrete should be damp, but there should be no standing puddles on the surface. That moisture helps open the capillary pathways and draw sodium silicate deeper into the slab before crystallization begins at the surface. Using a standard low-pressure garden pump sprayer, apply the sodium silicate solution evenly over the concrete. Keep the surface wet with the solution for 30 to 60 minutes. During that period, use a soft push broom to keep brushing and redistributing the liquid toward any areas that begin drying faster than the rest. After the dwell period, thoroughly rinse the driveway with clean water. Use a squeegee or wet vacuum to remove every remaining puddle of excess, unreacted sodium silicate. If sodium silicate is allowed to dry in puddles on top of the concrete, it can react with carbon dioxide in the air and leave behind a glass-like white sodium carbonate residue that may require mechanical grinding to remove. Once the excess is gone, allow the driveway to dry for 24 hours. Stage 4. The golden Kintsugi vein. Now prepare a high-performance clear 2-part structural epoxy, such as Sika Concrete Fix, or a flexible self-leveling polyurethane joint sealant, such as Sikaflex, depending on whether the crack remains active or is completely stable. Mix the clear resin and blend in brilliant gold, bronze, or copper metallic mica powder. Another option is to mix the clear resin by itself, pour it into the crack, and then lightly dust gold metallic powder or gold leaf over the surface while the resin is still tacky. Applying the metallic material to the surface often creates a much brighter, more reflective vein. Using a syringe, slowly inject the gold resin along the entire crack. Overfill the opening slightly so there is enough material to compensate for any downward seepage during curing. Keep the applicator nozzle directly over the crack as you work, so the resin doesn't drip across the surrounding concrete. Allow the material to cure for 48 hours. Finally, use a sanding multi-tool fitted with diamond grit sandpaper or a silicon carbide rub brick to grind the slightly overfilled resin until it sits flush with the surrounding concrete. Brush away the dust. And there it is, a smooth, shimmering golden vein running permanently through your restored slab. Section 6. The Soji Mindset, the secret of preventive maintenance. Now that the driveway is structurally restored and visually transformed, how do we keep it looking this way forever? This is where we turn to the Japanese concept of soji. In the West, home maintenance is often treated like a stressful war. We ignore things until the house becomes filthy or something begins structurally failing. Then suddenly, we launch into a frantic weekend battle. We rent a powerful pressure washer, spend an afternoon blasting the driveway, and feel satisfied because the concrete looks clean again. But here is the dirty secret of the pressure washer rental industry. That high-pressure stream may be quietly damaging the driveway. Concrete develops a thin, dense surface layer during curing, often called the cream. This layer naturally helps seal the capillary pores against the surrounding environment. A pressure washer operating at 3,000 psi can behave almost like a mild abrasive sander, wearing away that protective layer and exposing the microscopic sponge beneath it more than ever before. Every time you wash it aggressively, the next stain can penetrate faster and deeper. Even worse, pressure washing can leave uneven permanent striping patterns that become obvious weeks later when direct sunlight hits the surface. The Soji philosophy approaches maintenance completely differently. Instead of waiting for a crisis, it emphasizes small, consistent acts of gentle cleaning and care as a form of prevention. In Japan, children sweep their classrooms every afternoon. Monks rake temple gravel early each morning. The idea is simple: stop dirt, biological growth, and organic matter from building up and bonding to the surface in the first place. Use inexpensive, gentle chemistry rather than destructive brute force. Instead of reaching for a pressure washer, the Japanese turn to oxygen chemistry. One option is a white powder known as sodium percarbonate, the active ingredient used in oxygen bleach. When sodium percarbonate dissolves in warm water, it breaks down into washing soda and hydrogen peroxide, releasing millions of active oxygen bubbles. You can actually hear the reaction, a soft, steady fizz, as those bubbles develop inside the pores of the concrete. As they expand and rise, the bubbles physically push dead biological biofilms, including algae and mold buildup, upward and out of the concrete sponge from within. Organic stains are attacked at the molecular level without stripping away the protective cream of the concrete. The same Soji principle can also be applied to weeds growing in concrete joints. Putting plastic weed fabric, or boso sheet, beneath gravel does not solve the problem. Dust and leaves carried by the wind eventually settle on top of the fabric and decompose, forming a fertile layer of soil. Weed seeds land on that new soil, germinate, and send their roots down into the fabric, making the weeds extremely difficult to pull out later. To manage weeds in expansion joints without spraying toxic, carcinogenic chemical herbicides, such as Roundup, the Soji approach offers 3 inexpensive, highly effective kitchen-safe options. 1. Thermal weed torching. Use a simple propane weed torch and pass the flame quickly over the weeds. A few seconds of intense heat ruptures the plant's cell walls, stops photosynthesis, and causes the weed to wither and die back to the root over the following days. 2. High-concentration horticultural vinegar. Mix a 20% acetic acid solution with a small amount of dish soap, which acts as a surfactant, along with 1 cup of salt. Applied on a warm, sunny afternoon, this natural, non-selective spray quickly breaks through the protective waxy coating on the leaves and destroys the foliage without chemical runoff. 3. Mineral salt sterilization. Spread ordinary rock salt or pool salt directly into cleaned pavement joints after the weeds are gone. Then water it lightly. This creates a highly concentrated, localized hypertonic soil environment that dehydrates future seeds and prevents germination. Just make sure the salt is never used near lawns or trees, because it can permanently sterilize the surrounding soil. Section 7. Reclaiming your home. The economics of empowerment. Now let's step back and look at the larger picture, because this is where the real climax of the story begins. This was never just a technical lesson about sealing a gray slab of concrete or pouring gold-colored resin into a crack. This is about taking back your power, your independence, and your sovereignty as a homeowner. The modern consumer economy is intentionally structured to make us feel helpless, dependent, and constantly short of money. From an early age, we're taught that our homes are complicated and fragile systems that ordinary people should never try to maintain themselves. A shingle blows away. A wall starts leaking. A driveway develops a crack. We're trained to panic immediately, pick up the phone, and hand over our hard-earned savings to a certified gatekeeper who charges enormous fees for what is often straightforward material science. So let's look at the cold, hard numbers behind this driveway repair. The contractor wanted $8,000 to tear out my existing concrete and replace the entire driveway. If I had accepted that quote, I could have spent months working just to repay the expense, or watched a huge portion of my savings disappear. And after all of that, the replacement slab could easily have started cracking again within 3 winters, because the contractor has absolutely no financial incentive to carefully compact my soil or apply an invisible, permanent sodium silicate densifier. Now compare that with what we actually spent on this Japanese-inspired restoration. 1 gallon of professional-grade raw sodium silicate, or water glass, from Amazon, $25. 1 2-part cartridge of self-leveling polyurea concrete joint filler, $40. 1 small bag of brilliant gold metallic mica pigment, $10. A wire brush and cold chisel already sitting in my garage. The total material cost came in at less than $100. By avoiding the contractor cartel and using simple, documented molecular chemistry, we kept more than $7,900 in our own family budget. But saving money is only the first reward. The second reward is structural. The contractor's new driveway mix could have contained 40% unreacted free lime, leaving it vulnerable to the next severe freeze. Our existing driveway, by contrast, has now been chemically densified from within and filled with insoluble calcium silicate hydrate crystals that continue becoming stronger and harder every decade as trace hydration continues inside the concrete. And then comes the third reward, the one that may last the longest, the psychological reward. Now, when you walk out your front door, you no longer see a maintenance battle you're losing, or an embarrassing reminder that your property is deteriorating. Instead, you see a breathtaking golden vein shimmering through a beautifully preserved pale concrete slab. You see your own creativity. You see your own intelligence. You see the result of your own physical effort embedded directly into the ground beneath your feet. You have stepped away from the passive consumer cycle and into the active role of an empowered home optimizer. The golden thread. Look down at your driveway one more time. What do you see? If all you see is a gray, cracked, crumbling slab of concrete, remember this: those fractures are not a crisis. They are not an invitation to hand an $8,000 check to a contractor who will arrive with a heavy jackhammer and tear through both your driveway and your budget. Those cracks are an opportunity. They are a canvas. They are a physical invitation to slow down, return to the roots of history, and use the beautiful, honest science of material chemistry to heal your home from within. Your home is a living story, a reflection of your family's journey through every changing season. It expands beneath the summer heat. It contracts in the cold of winter. And yes, sometimes it breaks. But just like the ancient pottery restored with gold for Shogun Yoshimasa, a home that has been broken, repaired, and celebrated by your own hands can become far more beautiful, resilient, and valuable than one that has never endured a single storm. Let those golden veins in your driveway catch the sunlight. Let them become a shimmering monument to your independence, your resourcefulness, and your decision to preserve what still has value instead of blindly throwing it away. If this story changed the way you look at the ground beneath your feet, and you're ready to join our growing family of homeowners reclaiming their budgets through the roots of science and history, hit that subscribe button, ring the notification bell, and share this video with a neighbor who is standing outside right now with a pressure washer or a contractor quote, and tell them to stop. Thank you for walking this path with me today on The Roots Survived. Remember, you don't have to be stronger than the forces of nature. You only need to be more patient, more consistent, and more willing to listen to the science. What crack on your property are you going to turn into gold this weekend? Let me know in the comments below. Until next time, keep your roots deep, keep your home strong, and I'll see you inside the next open vault.